Up today's lecture, we're going to cover a couple more pieces. We already have walked our way through most of the examples. We're just going to cover example number 18. And we have a couple other pieces just to talk about very quickly. First, as we work through our way to the end of this chapter and the end of this section 3.2, some key considerations with regression. You have to have an explanatory and response variable. That's what you're trying to build. You're trying to build a model. And in so doing, you want to what? Have an explanatory value which explains / predicts your response variables. So key for anything in regression, you definitely must have an explanatory and response variable set that are defined. We're only working with a linear model. So everything we talk about in the context of regression for our course at this stage is always focused on establishing a linear relationship between our explanatory and response variables. Remember, the correlation coefficient, the least squares regression line, so on and so forth, they all work off of a linear relationship. Remember again, association with cause versus causation, or correlation and causation. Just because something has a high correlation does not necessarily mean that one variable causes the other. There are many other factors that might need to be considered, other variables that also happen to exist somehow that we can't control for, that actually determine and define what we might see as a association between two variables. So don't necessarily assume just because you have an association that your response variable is caused by your explanatory. And also remember, our correlation coefficient is quite resistant to outliers and other values that are outside of the quote normal patterns of our data. We saw a correlation coefficient is definitely a non-resistant, and for that matter, the linear regression equation is also non-resistant. But we're going to talk about this in the context of outliers in a slightly different way than we did in chapter 1. Again, we said outliers are observations that just kind of don't fit the overall pattern that we happen to observe in our variables. And that's still true. Outliers might have an impact on regression, but they don't necessarily have an impact. We are going to find that some outliers are going to be classified as what we call influential points. And as an influential point, we're going to see that that particular type of outlier that gets this little extra classification as an influential point, it truly does impact the regression line and the work that we do with our regression model. So what we're going to do very quickly, as you read through pages 187 through 189 in the textbook, you wound up on page 189 with this little model of a Gesell score and the age in which a child spoke his or her first word. And there were two things to notice, and again, this is just taken straight from the book. There were a couple points, child number 19 and child number 18, that look like they might produce or that would be classified as an outlier. We could say child 19 is an outlier in the Y direction. Child 18 is an outlier in the X direction. When all 19 data points or all the points are considered, we have one regression line, and that's what you see up top, and one correlation coefficient. Not particularly strong, but a negative association, a moderate association, if anything else, with an R value at negative 0.64. If we run this same regression model and take child 19 out of the equation, well, we do get an improvement or a stronger correlation coefficient. It's negative, but it is a stronger negative correlation coefficient. But if we look real closely, we see that our regression line did not change very much. So what's the point here? Just because you're an outlier does not mean that you are an influential. You might not have a great impact on our regression line. Take a look at child 18, and what you see is a very significant change in the correlation coefficient. It's now gone down to what? A negative 0.33. We're hardly seeing any correlation at that stage. That's a very, very weak negative correlation. But look also at what's happened to the regression equation. Our y-intercept value has gone down a little bit, not significantly, but a little bit. But look at what happened to the slope of our regression line. It's changed dramatically. When we remove child 19, the slope of that line, 1.127 versus 1.193, not much of a change. But when we go from negative 1.27 to negative 0.77 and look at the shape of these lines, that is a significant change. And so what would we say here? We would say that child 18 is an influential point. And one of the things to note about an influential point is it attracts the regression line. What do I mean by it attracts the regression line? Well, this point, remember, we're trying to do what? Minimize the sum of the squared residuals. When we have a point that sits kind of isolated, particularly in the x direction, we need to what? Try to minimize the impact of that residual. We're still going to have a residual, but we need to what? We need to kind of bring our line, not bend our line, but just kind of turn our line so we get closer, so that we minimize, let's not say minimize, let me say reduce the size of that one particular residual. All the other residuals change as a matter of fact as well because of this point, but the bottom line is this point is so influential that it truly alters the shape in a significant way, in a noticeable way, of our regression line. Now, are we safe to say, well, we should just throw out these observations and just go ahead and run our regression and say that's what we'll hang our hat on? The answer to that is not really. Just because a point is influential and you think, oh, it really throws my results off, we can't just pell-mell say, I'm going to get rid of this point. It's a legitimate observation. It requires further study. Maybe we recorded something wrong. Who knows? Then again, this might be a truly, truly legitimate observation as well. So just because you have an outlier, or just because you have an influential point, using this new language, don't necessarily think, well, I can just ignore this and work with all the other points and let my model work from there. So just be aware of that piece. We're going to do one more thing from a video standpoint, going back to our little correlation applet, and let you see just a little bit of this concept again, just through an interactive view. So this will cover the last part of chapter 3. So we're going to talk about and use our little correlation applet that we used a couple classes ago to just describe and visually show what an influential point tends to do. Here you see a positive correlation, relatively strong, just about 75%, a positive correlation, positive association between my two variables. And we're going to consider some, what we believe are potential outliers, both in the upper left and in the lower right. And what I'd like you to do is keep an eye on what happens to our regression line. First, I'm going to add an outlier in the upper left. And you notice our regression line certainly has moved. Our correlation coefficient has been hit very, very hard by this point. If I turn it off, regression line goes back to where it was. Correlation coefficient goes back as well. So point number one, we'll see it when we go over here. So let's just hit down in the lower right. Now my correlation coefficient has even gone negative, and look at the slope of my regression line. What used to be positive and relatively significant positive slope has now turned into a negative slope. Why is this happening? Well, both this point up here in the upper left, and if I add one in the lower right, they both have very large residuals. And our regression line is going to be drawn toward those residuals. Watch, this piece is going to do what? It's going to move up. Because it's trying to do what? It's trying to minimize this residual. Over here, what's happening? Well, the line's moving down. Why? Because I'm trying to minimize or at least control this residual a little bit more. If I just kind of let things stay like this, I would have a ridiculously large residual. Now, influential points are ones that make a marked difference in your regression line. Sometimes, for instance, let me just add a little point here. My regression line hardly moved. I'm going to turn it on and off. You can see that it moves, and that's not necessarily an outlier, but that would be an example of a point that really doesn't have much of an influence. So here's the key takeaway that I want you to be aware of. In general, influential points are going to live out for large values of x. We can get influence for high values of y and a low value of x as well. But in general, where can you look most likely, where are you most likely to find influential points? It's going to be for large values of x. And again, why? Here's the other point. You'll read this in the textbook. The regression line is drawn towards influential points. When I put this point back out here, I need to account for it. I need to do what? it's supposed to have a very large residual. Well, I got to find some way to manage that because I'm trying to minimize the square of my residuals. If I just kind of, quote, ignore this point, I'm going to have bigger squared residuals for sure. I need to try to account for it. And what we say is the line is drawn. Our regression line is drawn. It's attracted towards those influential points. And if those influential points, to be influential, that's not very influential. That didn't move too much. But if I come down here, hey, I am really, really what? Starting to move with this point. Look what happens as I go up here. Little bit of movement, but not a ton in terms of what happens with my regression line. So the bottom piece to recall, again, is look for observations, potential outliers that have large value of x. Those are the ones that are going to be candidates to be your influential points.